Hello, and welcome to the PowerTest 25 conference hosted by NETA. I'm Ellen Parson, Editor-in-Chief of EC&M, and I'm here in Orlando to learn everything I can today about electrical power safety and reliability from some of the leading subject matter experts in the field. And I have one of those subject matter experts with us today, Joseph Aguirre. He is the National Technical Service Manager at Spark Testing North America. Thank you for being with us. And we really want to just kind of go over the key takeaways from your presentation. I know you gave several presentations today, but this one in particular that was of specific interest to our audience, EC&M, is advancements in stationary battery testing for renewable energy applications. So if you could just start with, a little bit of background on your company, your role, and kind of how that works into the PowerTest audience, like how that fits in. And then we'll move into some questions.
Awesome. So a little bit about my role. So as the National Technical Service Manager for the U.S., what I do is I oversee all of the NETA aspects of our organization.
Okay.
So that's just the P&L, the safety aspect, the marketing. So pretty much everything that has to do with running the NETA business for Spark testing. And within that, as far as the renewables go, we work a lot with like leawards, CAMs, different manufacturers and different asset owners to do their actual electrical testing or their NETA testing of all their equipments, whether that's the actual batteries themselves, the transformers, the high voltage breakers, all of their electrical assets. We play a part in playing those to keeping those up to date and up to standard.
And is that before they actually get to the installations, or like, let's say it's a solar farm, or what is it, like all these different types of applications? What kind of markets are it could be any kinds of markets that use solar, or is it only solar, or
It could be solar,
wind?
it could be natural gas generation, as far as all the other kind of generation aspects are out there. So we play in all spaces, not just renewable. So with the renewable space, it's predominantly solar, wind, mostly on the solar side. So within those sites, we'll typically do night outages because it is solar.
Right.
That way we're not impeding any kind of production on their end.
Yeah.
And then we will test the batteries, the station batteries, which are very critical for the infrastructure, and then test the transformers that are feeding those, etc.
Okay, perfect. So just to kind of go back to basics for the presentation, why are stationary battery systems, why do they play such a pivotal role in enhancing the grid stability? Let's start with that. And energy storage capacity, because that's obviously becoming more and more popular and necessary as these renewable components become part of, utilities and all the different things.
Yes, ma'am. So basically the intrigue on the batteries itself is you want to store that capacity or that current, that voltage onto the actual battery itself. That way, whenever it's in need, you can actually use it and put it back on the system. So as solar is going, typically you have you're producing it, so you're putting it back on the grid, right? So you could sell the excess or whatever is needed. So if you needed a spot check of 100 megawatts, boom, you could put about 100 megawatts on the line instantaneously, utilizing its batteries. However, whenever the sun is not shining and you still need that demand for a high influx for whatever reason, you still have that capability without all that stored energy. So without that, you would only be at the mercy of the sun. So during the longer winter nights, right?
Yeah.
Now you have that capability giving that extra load onto the system, or putting that extra power, that extra megawatts on the system whenever the inductive load is a lot higher because people are running their heaters and things like that. So it's making that load at nighttime when it's colder much higher, so you can put that much load back on the system to keep it stable.
Okay, that makes sense. What are the key differences when we're talking about the stationary battery testing methodologies in these renewable energy applications like PV, or it's wind or PV, versus traditional grid storage? Like, can you kind of do layman's terms on that? How does that work?
So it's a very good practice just to have that. So a lot of times generation, they make a surplus. So actually they're putting energy on the lines itself when it's not even needed.
Okay.
And now you have a way to store this energy and actually just use it when it's called upon. So it's way more efficient in the longevity of in the scheme of things. So a lot of times there's need to move up the load production, but it's only for short bursts, right? For short time durations. And with the batteries, you can basically just flip them on when you need it and flip them off when you no longer need it.
Okay, as far as the testing goes, then is this something that you go in and do this, or this is something they do themselves, and then you teach them how to do this, or How does that work?
So it could be either or. Most of the time that we go in because we're subject matter experts at that.
Yeah.
So we'll go in and do the load bank testing. We'll go in and do the battery impedance testing. So we could tell them the overall health of the battery system. That way we could say confidently that these batteries can store as much amp hours or megawatt hours as they stated that they can store. And that way we could push that on the grid and have a high confidence that we can do so.
Okay. I know in your presentation you talked about advancements in technology or diagnostic tools, predictive modeling techniques, real-time monitoring, how those can improve reliability and efficiency. Can you talk a little bit about that? Any trends there?
Yes. So the biggest thing is AI. No, yes, right. Okay. So the AI is the biggest predictive modeling tool that we have available. But however, the tool is only as good as what data you input. So whenever you're looking at the test results that you have, you need to make sure that it's accurate and precise, because if one bad data point can actually say that a battery may fail sooner than what it should be, right? Or it's going to say it's going to last longer than what it should be, which actually puts more jeopardy onto the system stability. So the AI algorithms that they have now are decent, but it's still going to take a
You still have to check them. You're right. And the person has to have the knowledge to know what's
correct.
Inaccurate.
It's better right now. It's still better to use the human eye versus using the algorithms as of today.
But are you already using that? Like it saves you lots of time, or how have you like implemented that so far?
So within those, not just AI generated, but a lot of software nowadays will give you the red flags, right? So you'll send in the set parameters on there. So if the cell voltages drop at a certain level due to an individual cell in a battery string going bad, then that would flag it saying, hey, that the voltage drop is too low and that cell's going bad. So you know to replace that one battery versus replacing the whole string. And that way you can still keep the reliability, change that out, and now you're still keeping it in production and knowing that the capacity level is great on those batteries.
Okay, awesome. I know you also had a section in the presentation about challenges. So what are some of the biggest challenges in the stationary battery testing for these renewable energy applications? What would you say those are?
The biggest challenge is educating the customer.
And then how do you address the challenges after that?
So it's educating the customers because time is money. You were talking about anything, especially with our generation, that some of these customers only want to do a 1 hour load bank test. However, it's not giving you the full picture of what's going on with the battery. It's more of an endurance test. Right, so the best way to look at that is instead of doing a 100-meter relay, which is that 1 hour test, you want to do a longer duration test, or basically like a 400-meter relay test versus just that 100. Because that 100, you might be good at a short spurt, but what happens on those long winter nights when you need that power for 5, 6, 8 hours, and now your battery system can't sustain that, you want to ensure that versus just those 1 hour bursts. So that way you can get the overall health of the battery during cell.
Okay. So is it obviously weather issues or like electric vehicles? What are they needing to, store this energy for? Are there some big things coming there? The EVs and what else?
So EVs are a big thing coming in right now, because right now, if everybody in the whole world went to EVs right now, we don't have the electrical capacity to charge all of these. If everybody had to go in at once. So you could say about fuel, right? So if everybody went to the gas station all at once, there's going to be mayhem. Right?
That's a good analogy, right?
But right now, we don't have the infrastructure to handle all that load. That's why a lot of people say do the charging at night, because there's a lot less capacitive or inductive load going on at the time.
Okay.
So since you're wanting to charge these batteries, and a lot of not just EV batteries, but just the renewable batteries on itself, just the mining on those takes a lot of power on those. So you need to offset somehow.
Okay. Definitely. So wrapping it up, we want to talk about, were there any other big things? You mentioned AI, other big things that the audience should watch for in this space as far as emerging trends go, or advancements, anything that you have your eye on that everyone should be keeping an eye out for?
Yes, they're making more efficient batteries now, where you have a longer lifespan versus just using the lithium ions, which are very, very important right now. Now you have like other than lead acids, you have like flow battery systems now, which give a a better charge off, and then they're also 25 plus year battery lifespans versus like the 10 life year, 15 life year cycles on those. So now you can upgrade those batteries and look at those different test methods. You could do IR scanning on these to see if there's any kind of heat degradation on those.
Right.
And as the battery starts heating up, then you're going to start losing the efficiency and losing the life cycles of those batteries. So just doing periodic scanning and thermography trends really help out the life cycle.
Okay, that's good to know. Well, thank you so much. I think we're about ready to wrap up for today for taking the time to talk with EC&M about the key takeaways from your presentation. We really appreciate it, Joseph. And I think that's it from PowerTest 25 in Orlando. I'm Ellen Parson with EC&M. Thank you and have a great day.